Welcome to Guy Academy. Today we will be talking about rational, exponent, equations. So, first off, let's start. What is a rational exponent equation? Well, to begin, a rational number, you can look at this ratio right here. A rational number is a number that can be written in a ratio, so 2 to 3, or most people write them as a fraction, so 2 to 3, or 2/3. And then exponent. The exponent is the number here that a number is multiplied to, or a number is multiplied in different times by. So 2 squared would be 2 times itself, and then 2 cubed would be 2 times itself times 2. So let's combine the two. So this is a rational equation, 6 to the 2/3. As you can see, there's a ratio or fraction right there in the exponent. So what do we do with this? How do we solve this equation? Well, here's the trick. This bottom number right here, we'll first take that and we'll create a root. This number will go right here to define the root itself. So in this case it's a 3, so it will be a cube root. Then we'll take this, our base number, 6 right here, and then we'll put it under the root. And then we will take our 2 right here, and then we will put the squared either in here, or you can also place it on the outside of the root. Either place works. So now you have the cube root of 6 squared. So now that looks like a solvable problem. So 6 squared is 12. So now we have the cube root of 12. We'll put it into our handy dandy calculator, and that equals 2.289. And there we go. That is how you solve a rational exponent equation. So let's go ahead and look at another equation. So as you know, when a number such as this, the cube root of 2 cubed, you've been taught so far that these two numbers counteract each other. Well, here's why. So if we take this rule and we apply our rational exponent rule to it, we can turn this into 2, then we'll take this 3 and put it on the bottom, and then we'll take this 3 and put it on the top, and now we have 2 to the 3 over 3, which also equals 2 to the first, which equals 2. So that is an algebra understanding of how those two 3's counteract each other. So let's go ahead and do some example problems. So in a test or in a real situation, you may see a problem such as this. 27 equals x to the 3 halves. So we're going to go ahead and put this into our form of the square root of x cubed equals 27. So then, to cross over our square root, we will square each side. So we'll go ahead and square and square. So then we will get 729 equals x cubed. So now we'll just go ahead and do the cube root to move that cubed over to where it needs to be. And we'll see that the cube root of 729 is 9. So x equals 9. Another similar question you may see, and I'll go ahead and write this in a different color just to keep it separated, would look like n to the 3 halves equals 125. So we'll go ahead and make that the square root of n cubed equals 125. So then we'll go ahead and square each side. So now we get the n cubed equals 15,625. And then we'll go ahead and take the cube root of each side to move that 3 again over to the correct number side. So once we take the cube root of 15,625, we get that n equals 25. So I hope I've helped you today learn how to use rational, exponent equations. Remember this rule. So we're going to put x right here. So y, z equals x to the power of z over y. Remember, our y goes to the outside of the root, and our z goes to the inside of the root. This will help you when solving all sorts of rational exponent equations. And thank you for tuning in today. We'll see you in the next one.